Hello, my name is Johnny Jones, and I'll be presenting to you guys today how to solve linear equations. So basically, linear equations are um, algebraic expressions where you use variables but not necessarily with exponents. Um, the standard version of a linear equation is y equals x. And here's a graph of y equals x. As you can see, with x is 0, y is 0, and as x is 2, y is 2. So basically x is your input and y is your output. So there are two formats for um, linear equations, and the first format is the slope-intercept form. And in this form, we basically have an equation of a line with in relationship to the slope and the y-intercept, and that formula is y equals mx plus b. And there's also the point slope intercept form, which is the format used for an equation of a line that has a slope but is also given with a point along that line for you to solve the equation. And usually that format is y minus y1 is equal to m times x minus x1. So we're going to talk about both. The first is the slope intercept form. And so I know you guys might be thinking, what is y equals mx plus b? Well, obviously, that is the formula for the slope-intercept form. But we're about to explain what each variable means so that you may understand the concept more. So, M stands for the slope of the line. It determines the shape of the line. It determines, you know, how steep or how straight does the line curve as it gets to each point. Then you also have y, which we explained is the output of the equation. Along the line, any given point is the output. You also have b, which is the y-intercept, which is also defined as the output of the equation where x equals 0. And then you have the x, which is the input of the equation along the line at any given point. So how do we solve it? Well, using the formula y equals mx plus b, usually each variable has a given number or a given symbol, and you have to solve for the remaining variable. Now, in beginning algebra, we usually solve for x and y, but as you develop your skills more and more, you start to be able to solve for the slope as well as the x-intercept. Now, we're going to talk about some of the different problems that you may encounter. So first, we're going to talk about the equation for the line where the slope is equal to 2 and the y-intercept is equal to negative 4. So you have to find the equation. Well, you plug in the givens for y equals ms plus b, you already know that the slope, which is m, is equal to 2. And we know that the y-intercept, which is b, is equal to negative 4. Now, given the y-intercept definition, we know that the y-intercept is the y value or the output where x equals 0. So given the y-intercept, we already know that x is also equal to 0. And you come out with something like this. So when y equals 2 times 0 plus negative 4, you have 2 times 0, which is equal to 0, plus negative 4. So you should get y is equal to negative 4. Now another problem we have is find the equation of the line where the slope is 1/2 and the point given is 3, negative 2. With that point, we have the first number, 3, which is in the coordinate point, the coordinate, and the point 3, 2, negative 2. 3 is the input, negative 2 is the output. So 3 is your x and negative 2 is your y. So now we have what y equals, but we don't necessarily have what the y-intercept is. So we have to solve for the y-intercept. So again, we plug in our givens. So y equals negative 2, m, which is equal 1/2, x equals 3 plus b, because b is what we're solving for. So we have this. Now, what we do is we automatically solve everything on both sides of the the equation. So negative 2 is out there by itself, so we're going to leave that for a while. What we're going to do is distribute that 1/2 into that 3, or multiply 3 times 1/2, and you should get 3 halves plus b is equal to negative 2. After that, you're going to solve by subtracting 3 halves to the other side, so you have negative 2 minus 3 halves. Negative 2, if you do adding and subtracting by common denominators, you should get negative 4 over 2 minus, or negative 4 over 2 minus 3 over 2, which gives you negative 7 over 2, which is your y-intercept. Now the point-intercept form. So basically, we're going to explain the equation y minus y1, which is equal to m times x minus x1. So again, we have y as the output of the equation. Well, y1 is the output of a given point on the line. M is again your slope, x is the input again, and x1 is the given point, is the input of that given point. So we're going to explain that further. But first we're going to learn how to solve for that. Well, with that formula, you usually going to plug in the givens and solve for the unknowns. And if you have more than one unknown, you're going to solve for y. So here we have the equation of the line with the slope of 2 and passes through the point 2, 0. Now this is the same problem from the slope-intercept to show you guys the similarities between slope-intercept and point-intercept, but you're going to get different answers, but it's going to be the same line. So now you have y minus y1 equals m times x minus x1. So you plug in your values. You have the coordinate again, 2, 0. X equals 2, y equals 0, or x1 equals 2, y1 equals 0. The slope is m equals 2. So now you have y minus 0 is equal to 2x. 2 times x minus 2. So when you distribute, you automatically get y minus 0 is equal to y. And then on the other side, you distribute that 2 into the x minus 2, and you get 2x minus 4. Allah. So now another problem, which is the second problem from the first, from the slope-intercept, we're going to find the equation of the line where the slope is equal to 1/2, and the point given is 3, negative 2. So again, we're going to plug in our values. And so negative 2 is our y. Y minus negative 2, we know a negative times a negative is a plus. So we're going to get y plus 2 on the one side. And so our slope is again 1/2. And now we have x minus x1. So x1 is equal to 3. We're going to do x minus 3. So we have y plus 2 is equal to 1/2 times x minus 3. So now we multiply on both sides, or we combine like terms. And now when we distribute that 1/2 into the x minus 3, we get x minus 3 halves. And so we have y plus 2 is equal to x minus 3 over 2. So then we're going to subtract the 2 to both sides because we're solving for y, remember? When we have more than one unknown, we solve for y. And now we have y is equal to x half minus 3 halves, or x minus 3 over 2 minus 2. And so voila. Now we must always check our work. There's only one way to know that we've done it right. Is if we check our work. So there's obviously more than one way you can check your work. We have graphs. So for the first problem, using the slope-intercept and the y-intercept, we found that, remember, that the graph was equal to, at the y-intercept it was negative 4, and at the x-intercept it was 2. You know, the x-intercept is when the y value was 0. And as you can see along this line, when the x value is 0, the line hits negative 4 on the y-axis. And when the y value is 0, the x value is 2. and the line hits 2 on the x-axis. And for the other graph, we can see that it's not as great, but we can definitely see the negative 7 halves, or 3.5, negative 3.5. So there you go for the graph. And we're going to check our work again. So in the slope-intercept form, we have to find the equation for the line where the slope was equal to 2 and the y-intercept was equal to negative 4. And we're going to also find the equation of the line where the slope is equal to 1/2 and the point given is 3, negative 2. So we're going to plug in our values. Obviously, we already did this, but we're going to check it again with the answer as well as the other side, and we're going to solve. So 2 times 0 minus 4 should give you negative 4. Negative 4 should be equal to negative 4. There we go, great. And so this is our problem. We have negative 2 is equal to 3 halves minus 7 halves. And we'll use 3 halves minus 7 halves is negative 4 halves. And so now you have negative 2 is equal to negative 4 halves. And when you divide negative 4 by 2, you have negative 2. So negative 2 does equal negative 2. In the point-intercept form, we have find the equation of the line with the slope of 2 and passes through the point 2, 0. And then we're going to also find the equation of the line where the slope is equal to 1/2 and the point given is 3, negative 2. So let's plug in the values again. Using this formula, y minus y1 is equal to m times x minus y. x1, we have 0 is equal to 2 times 2 minus 4. Well, 2 times 2 is 4, so we have 4 minus 4. 0 should equal 4 minus 4, right? There we go. Now we have negative 2 is equal to 3 minus 3 halves minus 2. So 3 halves minus 3 halves is 0. So 0 minus 2 should give 2. Yep, and it does. Negative 2 equals negative 2. So I want to give a credits, and this is the end of my presentation. But here are the credits for the presentation. Again, I'm Johnny Jones, and you guys have a great afternoon.